Hello everyone, my name is Shadeeb and I'm an instructor for today's class. We are going to review some of the chapters of FE's exam, and the first topic that we are going to talk about today's class is with electrostatics. Let me just share the slide with you so that you're familiar with what's going on and what's in your curriculum. So just give me 1 second, let me just pull that up. Share. I am pretty sure you could see my screen right now over here. So the topic that we're going to discuss today is about electrostatics. Okay, so first we'll just kind of review the entire topic. We'll try to go through what equations you would be needing in your exam and how you would be approaching them to solve those equations. And eventually we'll solve some practice problems. So first of all, my general question to you guys would be like, what is electrostatics and why do we need that? So for those of you guys already know the answer, good. But for those of you who do not know what electrostatic is, it is actually a combination from the name itself, electrostatic, as in static electricity. Now, obviously, we know that two charges, like if it's a positive and a negative, is supposed to attract each other. Similarly, if it's a positive and it's a positive charge, it's supposed to repel each other. Or if it's a negative is supposed to repel each other as well. But as an engineer, it becomes very important for us to quantify exactly how much is the force of attraction or how much is the force of repulsion, so that you can build on equipments based on that calculations. So the first topic that we're going to talk about is the forces. Like if I have two charges, for instance, charge 1 called Q1 and charge 2 called Q2. How about let me just pull up a Word file? That would be great. Let me just open a new Word file so that you guys could see. I am pretty sure you guys could see the screen just to make sure that I'm sharing the screen. Yes, I am. Okay, so supposedly think of it like this. Let me start with, I have two charges. I have a charge, positive charge over here, and I have a negative charge over here. Now, obviously, I said, if it's a positive and negative charges, there would be kind of a force of attraction, right? But I need to quantify. So let's call this charge Q1, and let's call this charge Q2. Now, if you're trying to quantify exactly how much is the force of attraction between them, we'll use this primary equation, this one right over here. So let me just pull it up using a snipping tool. Now, this is a very important chapter in your FE exam, so just try to pay attention. If you have any questions, please feel free to reach out through email. So now, over here, from the equation itself, is very self-explanatory. So basically, you're trying to determine the force on this charge Q2 due to this charge 1. Right? So because there is another charge over here, it's supposed to feel that force of attraction or that force of repulsion if it was same charges. So you're trying to quantify how much is that force. So you have to take the product of these two charges. Okay, so charges are usually labeled in coulombs. So it could be 1 coulomb and 2 coulomb or 2 coulomb, 3 coulomb, anything. Just have to take the product of the charges. And then you have to divide it by a constant, which is 4 pi E. E is the permittivity of the medium. And if it's just in air, like in normal cases where it's not inside any other medium, we are assuming it's in air, the value of E is fixed. It's 8.85 into 10 to the power minus 12. And R is the distance between them. R is the distance between the charge 1 and charge 2. Now, you can pretty much understand from this. You see over here, correlation between distance and the force. Now, as you can say from here, as you get the charge further and further away from it, there would be less and less attraction between those, right? So if I keep my, suppose like keep my charge Q1 over here, and I'm taking my charge Q2 further away from here. So there would be less and less attraction. So Q2 won't feel that attraction for Q1 anymore, right? So distance plays a critical role on how much would be that force of attraction, and it is related by square inversely proportional, square inverse proportional. This is a vector direction, and usually, as far as I know, in FE exams, they usually don't bother much. So you don't have to bother much, unless in certain cases, but we would go through those step by step. So this is the first equation. So just you don't have to memorize this equation because it would be given to you in your FE booklet. But what I want you to do is just kind of remember it so that for every second you don't have to skim through the pages to figure out where the equation is. Some of them just try to remember. It's much more easy. It saves you time. Now, the next equation over here, as you could see over here, now, now, we talked about the forces, right? But now you're trying to find out the intensity. Intensity, there's a slight difference between intensity and the forces. Now, when you're talking about intensity, you could see over here, the equation is more or less similar, but it is a product of like it's per unit charge. So over here, it's expressed in volt per meters. Okay. So let me just take a snipping tool just to make sure. It's given by this equation over here. Let me just scroll down. Just to make sure. Keeps on. Yeah. So as you could see, the force, as I was telling you, the force and intensity is related by the charge, right? So that's what I was telling you. So you could see over here, this is how it's given. Okay. So if you multiply the charge with the intensity, you're supposed to get back how much is the force. Okay. So if you're trying to you're trying to measure the intensity for a single charge, just one single charge. So electrostatic field intensity at point 2, that means at this point itself, like at this point, but due to this charge. Okay, so you have to pay attention over here. You're measuring the intensity at this point for this charge. So you don't have to take the charge of Q2. That's where a lot of people might make a mistake. You have to take the charge of this one because you're trying to measure how much is the intensity due to charge 1. Like read the question properly. Electric field intensity at point 2 due to charge 1. So that's where a lot of people make mistakes, is that they sometimes they skim through the question. Try to pay attention to the question so that you're paying attention to what is being required. And not just answer the wrong question, because the MCQs would try to make it a little more complex for you. So having said that, so make sure that you're taking the right charge, and it's the distance, it's the same thing, like how far. So if you're taking a charge a little further away, you'll find the intensity would decrease, right? Now, however, if it's if you're trying to find a line charge, that means not single charge. Let me just show you. Okay. So if you're trying to figure out how much is for a line charge, okay, in that case, you have to take the charge density, a line charge density. Okay, to take the charge density, 4 pi E and the distance. Okay, so you have to take the charge density, which is measured in coulombs per meter, divided by twice by ER, and that's how you figure out the line charge density. Now, if it's a sheet of charges, if it was just one single line, you take the line charge density. However, if it's a sheet of charges, you will find it's also in Coulomb, but since it's in like area, right? So it's meter squared. So it's Coulomb per meter squared. Just pay attention. But more or less, it's the same procedure. Uh, but the only difference you would see over here, since it's a line charge, you do have a component of distance. But when it's a sheet of charge, you do not have that component because it's kind of incorporated in this one. So you can see it's a meter square already. And this one was just meters. So that's why I needed to account for that distance. But this one is meter square already. Okay. As you practice more questions, I'm pretty sure you'll get a hang of it. But just so that you guys know. Now, moving on to the next. So you basically, just to recap what I just said, if you want to find the force between two charges, you just take the product of the charges and you divide it by a constant, which is 4 pi e. And remember, e is 8.85 into 10 to the minus 12, which is air, unless it's specifically stated it's something else. Then you use that, you multiply it with a different permittivity. But other than that, try to keep it at 8.85 into 10 to the minus 12. R is the distance between them. Electric field intensity is nothing but actually the force per unit charge. If you just look into this equation, you can pretty much say it's force per unit charge. So, and here, since you're trying to figure out at point 2, due to 1, just make sure that you're taking Q1 into the equation, and then you divide it by a constant 4 pi epsilon, and R is the distance between them. However, if you're trying to figure out about the line charge, okay, so here you have to take the charge density, where the unit would be in Coulomb per meter. So now you do have to pay a little attention in the constant. Uh, this is the constant in this case was 4 pi epsilon, but in this case it's 2 pi epsilon. We don't have to go into too much of the derivation because that's not important in exam. They will pretty much tell you like line charge density, and you know that this is the equation you have to plug in. Or they will say a sheet of charge, and then you know that this is the equation you have to plug in. Okay. So once we've talked about the intensity and the forces, let's just cover this last topic in electrostatic. The last equation that we will be needing is about how much is the charge enclosed. So supposedly I have a surface. I know the electric field intensity, which is measured in volt per meter. But I want to know exactly how much charge is that in that substance. So how do I figure that out? I figure that out using this equation. So if I multiply the epsilon with the electric field intensity, okay, epsilon with the electric field intensity, it would give me the total charge enclosed. Okay, so you would be able to figure out how much charge is there by multiplying this constant with the electric field intensity. Here. Just to make sure that we covered. Okay, so now we're just left with 2 more equations for electrostatics, and then we'll practice some general questions. Okay, let's just keep it over here. Now, the thing is, you want to measure so there are 2 ways of measuring electric field. Okay, so let's just start with this one. So basically what you want to do is you want to find the strand of the field, okay, and you basically know, like, it's like this. Let me just show. This is your distance, okay? So supposedly you have line of charge. So these are 2 plates. Okay, supposedly this is the negative plate and this is the positive plate. Now, obviously, from the name itself, there's a potential difference, right? So there's a difference and there's a potential. So this because it's a positive and negative charge, you can definitely say there's a potential difference, right? Now, the potential difference over here, they might give you a value. Like over here is supposedly 15 volts. Okay, so between a positive plate and a negative plate, I have a potential difference of supposedly 15 volts. And I know the distance between these two plates is supposedly arbitrarily 2 centimeters, for instance. So the question is, how much is the how much is the strength of the electric field strength, or electric field intensity? So how do I measure that? How do I calculate that? So in this case, what is the potential difference? The potential difference is 15. And exactly how much is the distance between them? It's 2. But be careful, it's 2 centimeters, right? This is where a lot of people would make a mistake. And that's where your answers won't match because it has to be in standard units. If you it's usually in MCQ, so if you see your unit was in volt per centimeter, then you wouldn't have had to bother. Suppose it was in volt per centimeter in the MCQs, then you would just straightforward say just 7.5 volt per centimeter. But unfortunately, it's an MCQ, and you figure out all your answers in volt per meter. So in that case, you have to make sure that this 2 centimeters is converted into meter. And how would you do that? You divide it with 100. So once you divide it with 100, you get your answer in volt per meter. Am I making sense? I hope so. So that's how you basically figure out how to find the electric field intensity. Okay. Yeah. Now, moving on to the next part of the question is the current. Now, let me just start off this very basic. So what is current? If I ask you what is current, we usually say the rate of flow of charge, right? That means how much charge is flowing every second, right? That's what we mean by current, right? How much charge is flowing per second. So if I say my current is 2 amperes, what do I mean by that? What I mean is around 2 coulomb of charges, not 2 electrons, 2 coulomb of charges is flowing in every second. Okay, that's what you have to pay attention to. So 2 coulomb of charges is flowing every second. Now, if you're trying to mathematically represent something as the rate of flow of something, then we basically have to use this dq by dt. This basically tells you the rate of flow of charge. So I think I kind of made sense. So just to recap what we just did, we tried to cover a very small topic right now, electrostatics. What we tried to do was we tried to figure out the basic equations over here and the equations that you basically need to know for FE exam. We tried to understand that if you have 2 charges, there's a force chapter, like what's the topic? So it's work, energy, and power. Okay, so we'll go through the first set of questions from work, energy, and power, or electrostatics as we prefer to call it. So we'll just try to go through a couple of questions related to this. So let's start with the first question. Let me start. How about I start sharing my screen again? Okay, so I'm pretty sure you guys could see my screen right now, just to make sure that you are. Yes, you are. Yeah. Okay, so let me just zoom it in a little bit. Okay, so how about this? What I'll give you, since this is the first question that we're trying to solve, how about I give you 5 minutes, uh, and like, uh, let me, yeah, let me just first give you 5 minutes, and you guys could try figuring out the solution, and then we would just come back after 5 minutes and try to see whether or not we are being able to solve it. Okay. So it's been taught, just trying to figure out how you can apply the knowledge that you have learned so far to figure out how to solve this like 5 minutes from now, okay? Mhm. You have 1 minute left. After that, we'll try to solve the solution. Okay, so let's go back to the solution. Okay, let's go back to sharing the screen. So coming back to the question that we were trying to solve over here, it's a pretty straightforward question. Try to visualize it, what's happening over here. Uh, First of all, you have a charge Q1, then you have another charge Q2. So the charge of Q1 is 10 to the power minus 6. Charge of Q2 is 2 into 10 to the power minus 6. So if I'm trying to figure out how much amount of work, so what was the equation to solve work, right? So work was nothing but force into distance, right? And there was another equation over here, if you recall. Let's just look into the equation. So first of all, look into this one and try to figure out which equation would be like the most convenient for here. If you're confused, uh, like you know that this is the equation that you have. Like one is charge uh, P1 by P2 O and E. Okay, so now coming over to the question over here, amount of work done to bring a charge Q1 from P1 in the presence of another charge P2. Okay, so over here, like the first thing would be to figure out the distance. Like, how do I figure out that distance? So for those of you who do not know how to figure out distance, it's usually given like this: x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square root over. Okay, so in this case, it's 2 minus O whole square plus O plus O. So obviously you can figure out the distance is 2. So your distance is known. Now the only thing is like you have to figure out from here is like obviously you need to figure out the forces, right? So how do I multiply the force? It was Q1, Q2 divided by, I think it was 4 pi epsilon into r squared. So how much is my charge? It's 10 to the power minus 6. What is my next charge? 2 into 10 to the power minus 6. And it was like 4 by 8.85 into 10 to the power minus 12. And the distance over here is given. So you basically use the distance that's given over here, uh, which is 2 squared. And unfortunately, you have to multiply with the distance again over here because work done is forced into distance. So you can basically say this one distance. So you can basically figure out your work done from here. Okay. So once you solve this, you would be able to figure out how much is your work done. Okay. How about we try to solve another question very similar to this one? So how about I stop sharing my screen again?